Hi. So the last video I did was about translations, vertical and horizontal translations, and I promised you that I would do one on the rest of the graphing techniques that we find in section 3.4. I'm going to use an online graphing utility. It's called Desmos, and the reason I'm using this online graphing utility is because it's just going to make this a whole lot quicker and simpler, and you won't have to put up with my bad artwork. So let's take a look at just real briefly what we talked about last time, because it may have been a couple of days since you looked at that. So we're going to start with just the basic, let's see, your book uses the parabola, so let's use something more interesting for us. Let's use 1 over x. This is kind of an interesting, actually let's use I don't want to do that. I want to use let's use a cubic, basic cubic. And I'm just going to put this in projector mode. Actually, I probably don't need to for this. Okay, now what I want to do is I want to remind you what happens if we add something to this function outside of the parentheses. So this is the f of x plus a, with just outside of the parentheses. So I'm going to add a number onto the back, and I'm going to let that number vary a little bit. And this is just Desmos's way of letting me play with this. So if I want to look at f of x plus x cubed plus 3, you can see the blue line looks just like the red line, but it's shifted up 3. If I make it -3, make it my adder -3, it moves down 3. Okay. So, and if I make it 0, in other words, I'm adding nothing, this graph again lies right on top of my original graph. So let's go up in here and take a look at what it would look like if I were adding inside my parentheses. So just ignore the a on the end, it's 0. I'm adding something inside now. And so if I make this be 0, I get back to my original. If I add a positive number, I move to the left. Now, like I said, this feels a little backwards, but just remember that horizontal results from adding inside the parentheses, and it feels backwards. And I pointed out to you last time that if we add both inside and outside of parentheses, we can get stacked effects. So we can shift both left and right. Now, today I want to talk to you about scale factors. And what a scale factor is if I multiply this function by something. So let's start with a simple one. Let's just say I multiply y equals. So I'm going to multiply my function by a number. Right now that number is 1. Now 0 isn't very interesting in this case because if I go to 0, I just get a flat line. But let's look at what happens when I look at, say, y equals 2x to the 3rd power. So I've multiplied my function by 2, and I get a steeper function. It gets steeper faster. Or sorry, it gets bigger faster. If I multiply by a number less than 1, I'm going for like 1/2, you can see that my orange function is shallower than my original red function. It takes it longer to get as big because I'm dividing by 2 effectively. Okay. Now what happens if I multiply by a negative number, say -1? Notice what happened. The function actually turned upside down. This might be easier to see with a parabola, so let's go to y equals x squared for a second. Now, if I make my multiplier just be 1, oops, let me get to 1. my orange graph lays right on top of my basic parabola. If I make it be -1, it's exactly the same function turned upside down. So a negative sign reflects across the x-axis. Okay. Let's go back to our cubic. Whoops. There we go. Okay, so like everything else now, we can combine all of these effects together. So I'm working now with my same function, and let's say that, so I'm going to make this go away. Okay. So if right now, my two functions are laying one right over the top of the other. There we go. Because I've added 0 inside the parentheses, added 0 outside the parentheses, and multiplied by 1. So my blue function is really the same thing as my red function. It's y equals x to the third power. Let's add 2 inside the parentheses, which gives me a horizontal, actually let's subtract 2. We've been going to the left. So let's subtract 2, which gives me a horizontal shift to the right, because I'm subtracting. Let's multiply, or add 2, 3, 4. We'll go 4. Let's subtract 4 for the same reason. So we subtracted 4. So what we did was we started with our original, moved to the right 2, and down 4. Now I'm counting from the point 0, 0 because I know that 0, 0 is on my original function. I also know that 1, 1 is on my original function, so I could count from 1 over 2 and down 4 and get to another point on the function. All right? Okay. Now let's stretch this thing out. Let's multiply it by 2. Well, we actually made it steeper. We made it more narrow. So you can see what's happened. My function has been shifted to the right, down, and made more steep. It's still got the same basic function shape as y equals x to the third power, but it has been adjusted because of all of these multipliers. The key thing to understand is it's been adjusted in a predictable manner. Okay. I hope that helped. I hope it makes sense. We haven't had a quiz in a while. I don't have my document camera set up. Let's see if I can make this work. I want you to describe all right, I'll hold it up for you in just a minute. A sec, I'm writing. You're going to describe how the graph of f of x equals 3 over x minus 2 relates to the graph of okay. There you go. Oh, wait, let me turn off my screen share so you can actually see it. Sorry, I'll use my document camera next time. Here you go. Here's your quiz. And what that says is this, oh, it's backwards. All right, never mind. We'll skip the quiz this time. I will put one on a later lecture. Everybody have a great day. I don't expect you to be able to read, mirror, speak. And I don't know how to make it mirror automatically. Wait, maybe I do. Let's try this. There, now you can read it. Okay, what that says is describe how the graph of f of x equals 3 over x minus 2 relates to the graph of f of x equals 1 over x. So this is your quiz. It is quiz 3. And what I'm looking for is shift. You know, is it shifted vertically or horizontally? Is it steeper? Is it less steep? The sort of things we just talked about. So write that out and email it to me. And you can just write this one in an email if you want. A picture is worth 1,000 words. So if you want to sketch the graphs and send that to me, that would work too. If you do sketch them, please don't use Desmos. That's kind of cheating. Do it by hand so that I know that you know what's going on. All right. I will. It's not really cheating, but I want you to be able to do this by hand. So no Desmos on this particular quiz. All right. I'll see everybody again soon.